Hi everyone, so in this Pencast, we're going to do number 19 from Homework 1. It says, a hammer taps on the end of a 4-meter long metal bar at room temperature. A microphone at the other end of the bar picks up two pulses of sound, one that travels through the metal and another through the air. The pulses are separated in time by 9 milliseconds. What is the speed of sound in the metal? So I kind of just went ahead and drew this little diagram of this hammer banging on this metal, and we see the wave in the metal and the wave that travels through the air. And we want to know the speed of this one. So I went ahead and put down our knowns and unknowns. We know that this metal bar is 4 meters in length. It's getting kind of messy here. And we know that the speed of sound through air is always, or usually, 343 meters per second. And we know that the difference in time of the two sounds reaching the microphone is 9 milliseconds. So basically, this equation over here on the left is going to be our best friend. It's a derivative of the equation distance equals rate times time, except here we have the distance of the bar equals the speed of sound through some medium times the amount of time it takes to reach the x length. So we can go ahead and start finding the time it took for the air wave to get to 4 meters, since we have the speed of sound of air and we have the length of the metal rod. So we can find that time and we can use that later. So x. So we just some algebra, we get time equals x over speed of air, and this would give us 4 meters, 343 meters per second, and that would give us 0.01166 seconds. And in milliseconds, because that's what the other time is in, it's 11.66. So this is how long it took for the sound to travel through the air, 4 meters. But since we know that sound travels through metal faster than it travels through air, we can use these two sound values to make another equation of delta t equals delta t of metal equals 11.66 meters per second minus 9 meters per second to give us 2. And here we have the time it took for the sound to reach 4 meters through the metal this time. So now we can find the speed of that sound, since we have the time and the length. So if we just use this equation again, metal, and we want to solve for this one, so V metal equals our 4 meters over our 2.66 milliseconds, sorry. That. And, I'm going to turn it back into seconds for the sake of time always being in seconds, so that's going to be 00266 seconds. So 00266. And that's going to give us about 1,500 meters per second. And this is the speed of the sound through the metal, which is a lot higher than it was through the air. Thanks.